Okay, here in example 2, we're going to apply angle side angle congruence to an example. They're kind of giving us a situation here talking about Navajo Native Americans often living in octagonal homes known as hogans. Use available resources to research the design of octagonal hogans. How can you use angle side angle and congruent triangles to find the area of the floor of the regular octagonal hogan? Okay, so basically just saying, if you want to know the area of this shape, like how much surface is there here altogether, can you just figure out the area of one triangle and multiply it by 6? Are these all the same triangles? Is there a way we can prove that? Because that would kind of save some time. If you didn't have to measure the area of the whole thing, you could just measure the area of a piece and say, okay, well, there's 6 congruent triangles in there, so it's just that area times 6. All right, so I guess they're not going to use that home anymore. They're going to use a different example now. A company that manufactures windows needs to determine the amount of glass required to make the hexagonal window shown. PQ, so PQ, and TS are parallel. That's what these two side-by-side lines mean. They're just saying that these lines are parallel. If they were to continue out forever, they would never cross. R is the midpoint of PT, and ST is 12 inches. So ST is 12 inches. R is the midpoint of PT, and PQ, ST are parallel lines. Okay. Because PQ is parallel to TS, the angle RPQ is congruent to which other angle by the alternate interior angles theorem? Okay, let's look up a picture of alternate interior angles. So alternate interior angles are these guys. Okay, so that's a good way to describe that. So alternate interior angles are like in this picture. So they're on alternate sides of the line, and they are on the inside of some shape we're making. We haven't bounded off this side to make it a triangle or a parallelogram or whatever, but they're on the inside. They're interior angles, and they're on the alternate side from each other. Okay, those will be congruent. Those will be congruent for the same kind of reason that I showed before, where I took the paper and I took one and I just spun it over to get to the other one. Because basically, like, if I could, I think we can recreate their picture of my lines. Pretty close, anyways. So what? They have two parallel lines and a diagonal line. Okay, so it's not pointing the same way as theirs, but hopefully you can see that, like, these black lines with the arrows would be like these blue diagonal lines. And then there's one that crosses through them. So our alternating interior angles would be like 2 and 1 are alternating interior angles. Okay, the unmarked one here and the unmarked one here would be alternating interior angles. Okay, so let's see what we have to do to use that. So so which one are they talking about? RPQ? RPQ, so this angle, well, the alternate interior angle would be kind of across this line down here. So it would be RTS. RTS. Let's label these. RPQ. RPQ is here. And RTS is here. And we're saying that these ones should be the same because of the alternate angle theorem. Alternate interior angle. RTS. Okay, because R is the midpoint of PT, TR, so what length is TR? TR is this length. TR must be congruent to, I'd say, PR, because the full line PT has been cut in half. So PR is going to end up being congruent. Right? PR is going to be congruent to TR. Okay. Angle TRS and angle blank are vertical angles. So where's TRS? TRS. So I'll label that yellow. TRS. And what is the vertical angle from that one? Well, it's across the vertex. It's over here. So that would be angle PRQ. We could call it QRP as well, but I'm going to call it PRQ. Okay. So then we're saying, therefore, these triangles, the triangle PRQ, this one, and the triangle TRS, this one must be congruent. Well, did we have an angle side angle pair in there? I think we did. So for the first one, we had this angle, this side, and this angle. And we showed that the two angles in there had a partner. So the red and yellow had a red and yellow here, angle. And the two sides that were the included sides were also congruent. So, all right, based off the angle side angle theorem of having congruent angle side angle with another angle side angle being congruent, then the whole triangle must therefore be congruent. Okay, let's see what else we got down here. Find the area of the window. Okay, so if the 6 triangles that form the window are congruent and the height of triangle TRS is 10.39 inches, how much glass is required to manufacture the window? Well, the area of any triangle is always 1/2 base times the height. Okay, so we do 1/2 of the base. Okay, the base they told us was going to be 12. ST is going to be 12. And then they give us a height. Okay, so we just do 1/2 the base times the height. And that is in square inches because we're talking about an area, which is a type of surface or a 2-dimensional unit. So we say square inches. Looking at that area of a triangle idea, to remind you why it is 1/2 base times height. The basic idea is this. So if you had a right triangle, then you could imagine that if you multiply base times height, you get a rectangle. So let me see how I want to do this. Let's go back here. Okay, so if I was just to look at this right triangle, okay, then if I multiply the base times the height, I get this rectangle. And if I just do 1/2 the base times the height, well, then I get half that rectangle. I get the area of the triangle here. Okay, so the area of a right triangle is 1/2 base times height. Now, can we say for sure that the area of any triangle is that? Well, we can kind of go through the steps to show it. So if the area of this piece is 1/2 the base times the height, and should be the same for this piece, right? Because this is also a right triangle. Now, bear in mind that any triangle that you draw can be turned into 2 right triangles. Okay, so this idea of 1/2 base times height definitely applies to right triangles. Now, I'm going to write out how I would get the area of this one. So if I call this length, let's call it x, okay, from here to here. So this whole thing was b. This little piece must be b minus x, right? It's the whole length minus that part that I defined from here to here. Okay, so let's find the area of both of these. Well, the area of the larger triangle should be 1/2 of x. X is our base of this triangle here. Okay, so 1/2 x times the height. We are going to add to that 1/2 of, so So for the area of this triangle on the left side, well, the base is b minus x. And then we multiply by the height. Okay, I'm going to remove a common factor in these. So both of these have 1/2 in them. Both of them have the height in them. So I'm going to say this is 1/2 of the height times, what's the remainder from this one? Well, there's an x remaining in there. And in this one, there is a b minus x. Okay, so now this x part that I originally had to add to this picture, it's going to go away because I have x and minus x. So those will go away, they'll cancel out, and we'll just have 1/2 base times height. Okay, so we still get 1/2 base times height even when we're not dealing with a right triangle to begin with. That is just true for any triangle. So the right triangle clearly follows the 1/2 base times height rule because it's just half of a rectangle that you would make by multiplying base times height. It's half of that thing. But if you have any other kind of triangle, well, you basically just say any other triangle can be divided into two right triangles. And those right triangles, if we find 1/2 base times height for each of them individually and add them together, we actually just end up getting we end up with the same result as just doing 1/2 base times height to begin with. Okay, so the fact that we have to add up, area 1 with area 2 actually simplifies in the end to the same exact equation as if we had just started with a right triangle. Okay, so this formula, 1/2 base times height, works for any triangle. All right, we'll move on to the next example in the next